Hello, fellows. Good morning, good afternoon, good evening, good morning again, with respect to the time that you'll be watching this video. So, this is Introductory to Maths, which is being offered in UB BSc Year 1 or Level 1, level 100, however you want to call it. And the course code is MAT 31. And okay, I'm here. The tutor or the man who is offering this course is Mapetla. There is my name. There's my name. There is my name. Mapetla is my name. I'm a former student from there. And then this is my number here, but this only applies to BW, right? Botswana. So then, yeah, the first topic that we're going to deal with is a prerequisite number 1 for maths, for introductory to maths, which is the topic of number systems. So number systems, we have types of numbers. These types of numbers, we have real numbers. Real numbers, I guess we all know what real numbers are. If not, I know we know, just that we believe you don't know. So real numbers, these are all numbers that we know, except imaginary numbers or complex numbers. And then rational numbers. So a rational means an expression over another. So rational numbers, these are really numbers which can be expressed in form of a fraction and integers. Irrational numbers, I was to say, these are numbers which cannot be expressed as a fraction. And yes, we'll get into details in the definitions. And then integers are simply whole numbers. Their negatives and the positives, including 0. And whole numbers, we know what whole numbers are. These are counting numbers. So these are simply counting numbers and 0. And natural numbers are indeed natural numbers, which are counting numbers. So here are our definitions. So we have real numbers. The notion for real numbers is an R which has been cancelled. Now I wrote the other bar on the left hand side, but you can write it like this. It is fine, not a problem. So yes, real numbers. So these are numbers that are represented by the real number line or in the real number line. That is, this includes all numbers except imaginary numbers or complex numbers, what I was talking about. So the examples is all numbers that we can think of except that number which has I, imaginary, right? Something like 2I or I cubed, whatever. But I squared, it's real. But anyway, okay, let's not go into that. But yeah, those numbers which have I, we know they are imaginary, right? So therefore, yeah, yes, we're good. We have numbers like 1, numbers like 2 are real, numbers like 1/4, root 5, cube root of 10, pi e, you know what e is again? Yes. So, and etc., those that I have not mentioned, because we have infinite numbers of real numbers. So yeah, number 2 is rational numbers. Rational numbers, these are numbers which can be expressed or which can be written in the form of P/Q or expressed as a form of P/Q. This is where the denominator is not 0 and this P and Q are both integer numbers. So these are simply fractions that we are used to from junior school or primary school, whatever. So yes, and then examples of such, we have 1/2. We can have a whole number 2. It can be expressed in form of 2/1. So still it is in the form of P/Q, and the Q will be 1, which is not 0. Then we are fine. And P and Q are both integers because 1 and 2 are integers. And 0 len can be written in such a manner, right? Please, there shouldn't be any misunderstanding or anything. So 0 can be written in form of 0/5 or 0/1, 0/2, but not 0/0, right? Because remember, we exclude these conditions. The denominator can be 0. So the denominator cannot be 0 strictly, but any other numbers can be zeros. So therefore, 0 still is a rational number. I guess we are good with that. And then, yes, we have 1/2, 2, which can be written in form of 2/1 or 4/2, either way. And then the other number is, or one of the examples is -3/4. The other one can be 1/9 and etc., those that I have not mentioned. So then we have, okay, some important note and B, when these numbers, so that is, when these numbers are written in decimal form, they either, this was supposed to be they either terminate or repeat, or they recur. Repeat is simply the same as recur. So it's either they are those. So therefore we have examples of, what is to terminate? What is to terminate is to stop, right? Is to stop, and to repeat means that something it is recurring or in a cycle form. It is coming again, going, coming, going, just like that. So terminating numbers, we have 1/2, or terminating fractions. 1/2, when you write it as a decimal, it's 0.5. And 1/4, it is 0.25. And jalo jalo, we have others say, they will satisfy us, or they will terminate, they will not repeat. And then repeating decimals, we have something like 1/3, sorry. 1/3, being written in form of a decimal, is going to be 0.333333 going on. You can say 3 infinite times. And that is shortened mathematically by writing 0. The repeating number, you put it a bar on top. You just write it, the very first one that is to repeat, you put a bar on top of it. So that will be how it is denoted in short form. And then you have numbers like 7/11. Writing it as a decimal is going to be 0.636363, on and on, counting 63 those infinite times. So in short form, we write it as 0.63 bar. This bar should be over 63. It should be over 63, right? It should be over 63. So okay, looks like I'm seeing things here. I mean, yes, that bar should be over. Yes, it should be over like that. Coming from 6 going on to 3, right? Coming from 6 going on to 3. So I think we are clear with that. And then we can have another example. And the example can be 13/15. Is it 15 or 18? I think it's 15. This should be a 5, right? This should be a 5. I'm sorry about that. So decimal form is going to be 0.8666 going on and on, but repeating, only the repeating set is to be put a bar on top. So whatever, we are going to write it as 0.86 bar just on top of 6, and so many others that we have not mentioned. So okay, the other form in which a function can repeat, as we can see, these here, it is grouping itself into some sets of 6, 3, 6, 3, 6, 3. This one is into sets, so when you put a bar, you put a bar on top of a set. But here it's only a single digit, so you're going to put it on top of that single digit. So now, some important note to be noted, or some important thing to be noted, is that you should remember that we can be given the repeating decimals, and we'll be expected to convert them back to fractions. We'll be given, for example, e.g., they will say convert 0.86 bar to fractions, or write it in form of P/Q. So then you have to find a way of converting it. So we'll do such examples during the course of time as we move on with the video. So I guess I was clear with rational numbers. And then number 3 is irrational numbers. Irrational numbers, they are written as these. Okay, I'm a bit skeptical about this sign. I don't know if it should be a pi cancelled, or it is that Roman figure too bigger, or written in caps. So now, okay, anyway, please, I don't encourage you to write the sign for this one, because it's really, really confusing and skeptical. Different books will give you different denotions. So let's ignore the denotion. So yeah, the denotion, I mean this, again, let's ignore it. So these are numbers that cannot be written in the form of P/Q, where Q it's not 0, and where P and Q are integers. So that is, these numbers, they can be written in form of a fraction, and that fraction, it is not going to satisfy either of the two conditions. If at all they can be written in terms of a fraction or in terms of fractions, that fraction is not going to satisfy either of the two, as we can see this example here, right? So yeah, stuff like that. But cube root of 3 or cube root of 2 over 4, something like that. As long as the number under root is something else. Well, numbers like pi over 2, numbers like that, they are irrational. So I guess I was clear with that. So then some important thing to note is that when these numbers are written in decimal form, they are non-repeating. They are non-repeating decimals. That means that the numbers, they don't really have a sequence of predicting what the next number is. So therefore, punching it on the calculator or in your computer, it is going to give you just different digits with no sequence. So that is how it is. And then root 2 as well, it has a similar thing. And then root 3, jalo, and cube root of 5, and so forth, and root 2 over 2. You can see that this one here is in the form of p over q, but the disqualification is here, is that p, which is root 2, now it is not an integer. So it is what is disqualifying it from becoming a rational number. Hence, it is irrational. I think I'm clear. And then some important aspects again to note, is that in most cases, these are non-square numbers that are under square root, and the same with non-cube numbers under cube roots, and the same non-quad numbers under quad roots or its fourth root, whatever. So I guess we are clear. I think now you can see that math is easy. And then question number 4, question number 4, the fourth type of numbers, it's integers. According to my order, it's integers. So integers here, integers, I'm canceling them, sorry about that. Okay, integers. So here it's integers. So these integers, these are counting numbers. So it should be these. These are counting numbers and their negatives. These are counting numbers and their negatives, including 0. That is negative numbers from negative infinity going on and on to -2, -1, 0, 1, 2, and then going on and on to infinity. So yes. And then whole numbers. So these are numbers. I don't know what was happening with my English, but it's bad anyway. These are counting numbers and 0 or n number 0. That is 0, 1, 2, 3, 4 up to infinity or positive infinity. So and then we have the 6th type, which is natural numbers. So these are counting numbers. You know, counting numbers. You can't start counting from 0, or you start counting from 1. You know, I get it in real life. So it's 1, 2, 3, 4 up to infinity. You count jalo, so on and so on. So now we'll be moving on with our video. Okay, we're here. Hi again, fellows. So yeah, now we're dealing with properties of real numbers. So number one property is ordering. So we see that real numbers can be ordered or can be arranged. So starting with the smallest or starting with the biggest, and this is with respect to their position on the real number line. So we have ascending order. Ascending order is when you are rearranging or ordering them starting with the smallest. So the smallest real number, so that is easy. And descending order, this is ordering starting with the big real number. So it is simply that. And rearranging numbers is simply ordering. So that is how easy it is. The second property is the law of trichotomy. Oh, I skipped the page, I'm sorry about that. Trichotomy is when trichotomy implies that when given two real numbers, given any two real numbers, those numbers can be arranged in 3 different forms. Form number one can be, if given the numbers as, okay, e.g., I'm sorry, I can't write because power has been cut off, so my pencil is not really position itself well. Given the numbers A and B, we say that these A and B, or remember that they are real numbers. So this A and B can be, they can either relate in such a way that A is smaller than B, or A is bigger than B, or A is equals to B. This trichotomy, tri means 3, remember? It's either this relationship or this relationship or that relationship. So there are 3 relationships that are possible. So this is trichotomy. Remember, we were taught in primary school what the 1-2. You'll have to insert a sign there or which one is greater. So there are only 3 possibilities. Is either they are equal, or either one is big, or it's either 2 is big. So this is just what trichotomy means. So that is it. So because of power cut off, I'm sorry, our video will stop here. Let me go back a bit and see. I think I forgot something. On real numbers, I did not draw the real number line. I did not draw the real number line. So I should have drawn the real number line just right here. So then let me see the correct ink or the convenient ink to use. Let me use red. So if we are to have the real number line, is going to be like that. No, this I used. Okay, let me see a different one. Yeah, what? I don't know which one should I use. Oh, okay, let me use this one. So that is for us to have the real number line. We are to draw. This is the real number line. It's a straight line, right? So this being the ends, but this power thing is really not doing me good. Okay, if we have 0 here, okay, let's just stop there because wow, I will ruin the whole video. But thank you very much, fellows. All the best. I'll continue with my videos with examples. Okay, I'll be finishing off all properties and everything, and then I'll do some questions. So have a nice day and all the best, fellows. All the best in your undergrad. I love you all, and tell others about these tutorials. Sure, thanks.